All right, good afternoon. Welcome, everybody. Hope all is going well. Just want to touch base with you guys real quick with reviewing point-slope form. So we're going to talk about point-slope form equations, how to identify the slope and the point, and then I'm going to go through one example with you guys for graphing, because that'll be on your homework that was posted on Schoology. So make sure you're checking into Schoology not only for these videos, but for your homework. So you'll notice here, point-slope equation right at the top. What we're concerned about are three things. We've got our slope, which is m. That's always this number here in front of the parentheses. And our point is x1, y1. Remember, our x-coordinate is always the opposite of the point in parentheses. So, for example, this first one here, we see that our slope is 2. X is the opposite. So x is 9, y is 8. So all we have to do for the first couple here is identify slope and point. If you look at the second one here, so we have our slope is 1/3, and our point, the opposite for x, so -7, y value -13. For equation 3, slope of -4/9, x value of 6, again opposite of what's in the parentheses, y value is 12. And the last one down here, and it's okay if we get some fractions, that's fine. We have -3 for our slope, and -3/5 for x, and 9/5 for y. I apologize if the little screen in the bottom is covering that up, but 9/5 for y. So that is our identifying slope and the point in point-slope form. Next page, we're going to show you how to graph these and get an intersection point. Again, in these videos, anytime you need to, feel free to pause if you need to, or rewind and go back. So on page 2 here, you'll see that we have 2 equations. When I get to the graph, you'll see that they're going to be in red and blue here to match up with what you see in the top. So our first equation here, not that you have to do this, but I did for sake of ease, we have our slope of -2 and our point at 9,1. And so if you look at our graph here, our point of 9,1 is right there. Our slope is -2. Since we're at the end of the graph, I can't go down 2 and right 1, so I'm going to have to work backwards and go up to left 1. And you notice I did that a couple times here on this graph. And then our second graph, again, identified the slope and the point. We're starting at 2,5, so I tried to make this starting points a little bigger. Started at 2,5, up 1/2, up 1/2. You can see our intersection point right there. So our intersection point is 6,7. So that works out pretty well for us here. I did not put the lines in yet, so make sure when you turn this in or when you finish it that you do put the lines in on your homework. I just wanted to make sure you knew how we got the points to get rolling. And then we got to check our answer, so we'll scroll down here a little bit. What I'm going to do is take this point 6,7, plug it into both of these equations, make sure it works. So if I plug it into the top one, let me slide this over just a tad, there we go. We do get 7 equal to 7. Again, you can see the steps there, plugged in 6 for x, plugged in 7 for y. 6 minus 9 is -3, we'll multiply there. Get +6, 6 plus 1 is indeed 7. I got to do the same thing for the second equation, so I'm going to plug 6 in for x and 7 for y. So same idea. We're going to do 6 minus 2 first, in parentheses we have 4, half of that is 2, and 2 plus 5 is 7. So again, just a quick rundown of not only how to identify the slope and the point, but then how to graph them and get your common intersection point for a system of equations. So worksheet 2 is posted. That is due by Friday. As always, if you've got questions, shoot me an email. I will be doing a live session for you guys on Thursday at 1 p.m. If that doesn't work, just email me and we can definitely set up another time. All right, take care.